All right, so let's first take a look at activators. So these are things that are going to donate electrons into our ring and in general make them more reactive towards electrophilic aromatic reactions. So the first and the strongest type of activators are going to be when we have a lone pair next to the ring. And these are going to be our strongest activating groups. So for an example, an alcohol would be one of these. Same thing with a deprotonated alcohol, but other things such as amines, right? They all have lone pairs that they can donate into the ring. Note that halogens are the exception. Even though they do have a lone pair that they could donate into the ring, they're still deactivators, as we'll see later on. And again, the reason for this is resonance. Right, we can take a lone pair, donate it into the ring, and move it all about the ring. And so in this case, resonance beats out induction, and these are strong activators. Next up, we have our moderate activators. So in this case, we have a lone pair next to the ring, but it's already resonating with other stuff. So we'll call that our moderate. So an example of this would be something like an amide. Right, this nitrogen can indeed donate into the ring, and it does definitely to some extent. This is still an activator, but it can do other things as well, right? Instead of donating into the ring, it can resonate with this carbonyl. And so since it's sharing these resonance structures, it's not as strong as the previous examples. Another example of this would be an ether. Right, same thing. It could donate into the ring, or it can donate with or it can resonate with a carbonyl ring. So those are our moderate activators. And then finally, our weak activators are just our alkyl chains. So maybe you have like a methyl or a terpbutyl or something like that. These are going to be weak activators. So any kind of alkyl chain will be a weak activator. And the reasoning for this is what we call hyperconjugation. Basically, these sigma bonds, these carbon hydrogen sigma bonds can still interact with the pi bonds, and they will weakly donate. So be able to spot an activating group and think about whether it's strong, moderate, or weak, and then be able to draw the resonance structures for these activating groups.